Good morning, I am Jessie Pius from Rohini College of Engineering and Technology. Today I would like to explain the dual nature of matter. The dual nature of matter is an important concept in physics and is basically the study of different nature that a matter possesses. Initially, the properties of matter or light were explained in terms of its particle nature. Corpuscular theory of light explained this. Later on, it was experimentally found out that matter does possess the properties of a wave. Hence, the matter is said to possess dual nature. That is, it has both the properties of a particle as well as a wave. Maxwell's equation of electromagnetism and Hertz's experiment on generation and deduction of electromagnetic waves in 1887 strongly shelves the wave nature of light. Thus, the wave-particle duality is an important concept in quantum mechanics, which describes that every particle, or more specifically, quantum entity, may be expressed as either a particle or a wave. This concept further helps to modify the inability of classical mechanics approach or theories to fully describe the behavior of the matter. De Broglie wavelength. De Broglie wavelength is an important concept while studying the quantum mechanics. The wavelength lambda that is associated with an object in relation to its momentum and mass is known as de Broglie wavelength. De Broglie waves. It is said that matter has a dual nature of wave particles. De Broglie waves, named after the discoverer Louis de Broglie, is a property of a material object that varies in time or space while behaving similar to waves. It is called matter waves. It holds great similarity to the dual nature of light, which behaves as a particle and wave, which have been proven experimentally. De Broglie hypothesis. With respect to the quantum theory of matter, de Broglie postulates the relationship between momentum and wave. Mathematically, it is given in the form lambda is equal to h by p, where p is the momentum of the particle under study and h is the Planck's constant. De Broglie wavelength for electrons. In the case of electrons going in circles around the nuclei in atoms, the de Broglie wave exists as a closed loop such that they can exist only as standing waves and fit evenly around the loops. Because of these requirements, the electron in the atoms circle the nucleus in particular configurations or states, which are called the stationary orbits. De Broglie wavelength formula. De Broglie reasoned that matter also can show wave-particle duality just like light, since light can behave both as wave and as a particle, and the reason that matter would follow the same equation for wavelength as light. Lambda is equal to h by p. P is the linear momentum. For de Broglie derived the above relationship. E is equal to h nu for a photon and E is equal to mc square. Lambda is equal to h by mc, which is equivalent to lambda is equal to h by p. Note that m is the relativistic mass and not the rest mass, since the rest mass of the photon is 0. Now if the particle is moving with velocity v, the momentum p is m into v. Hence lambda is equal to h by mv. Therefore de Broglie wavelength formula is expressed as lambda is equal to h by mv. Thank you.